Okay, in this video we're going to be talking about arithmetic series. Now we learnt what a sequence was, and a sequence was just a list of terms. And you can have two types of sequences. You can have an arithmetic sequence, or you can have a geometric sequence. And an arithmetic sequence is one which has a common difference. Okay, so a common difference between each consecutive term. For example, in this question here, the question stem would have a common difference, because if we take each term and the term after it, you have to add 5 to go to the next term. So the common difference between each term is 5. So if we have a common difference, it's called an arithmetic sequence. A geometric sequence is one which has a common ratio, and we'll do more on this in another video. But for today, we're just going to be worrying about arithmetic sequences. The question asks, find S12. And S stands for the series. And another way of saying series is the sum. So the question is telling us the first 3 terms, and we have to work out the first 12 terms added together. Now, we can do it one of two ways. We can either work out each term individually and manually add them up, or we can be lazy and just use a formula. The formula to work out the series of any sequence, okay, so S sub n, okay, we have an arithmetic sequence, in this case an arithmetic series, is S of n equals to n divided by 2 times by 2a plus d n minus 1. And in this case, n is the nth term you are summing to. In this case, n would be 12. A is the first term in the sequence. D is your common difference in this case. So the common difference would be 5. So let us work out what S12 is. Okay, to work out S12, okay, we would simply say it's the same as 12 divided by 2 times by 2 times the first term in the sequence, which is 8, plus the common difference, which is 5, times by n minus 1. So now let's evaluate this. 12 divided by 2 is 6. 2 times 8 is 16. Plus, in this case, I forgot to sub in 12 for n. So we can sub in 12 here. So 5 times 12 take 1. So 12 take 1 is 11. 5 times that is 55. Okay, and now we can just simply evaluate this. And the final answer would be 426. So this number states the sum of the first 12 terms in this sequence here. And it's all done using this formula here. So let's have a look at a few more questions which employ this question here. Okay, this is our next question. Greg goes fishing every single day for a week, and on the first day he catches 7 fish. And then each day after that he catches 3 more fishes than the previous. So how many fish did he catch in total? So in this case, they're asking for the total number of fishes. So let's first generate some sort of a sequence. So on the first day he catches 7 fish. And the next day after that, he would catch 3 more. So he would catch 10 fish. And the next day after that, he would catch 10 more fish. And the pattern continues until day 7. So whatever day 7 would be. So in this case, T7, I'll write. Okay, so that's the 7th day. So we know the start term here is 7. So we know that this is the value for A. And we know that the common difference between each day is simply 3. Because we're adding 3 between each of the terms. And we're asking for not how much did he catch on day 7, but how much did he catch in total across the entire week. So in this case, we would have to employ the arithmetic series for this question. So again, the formula is n divided by 2 times 2a plus dn minus 1. And we can just sub in our values. So we want to work out what is S7. How much did he catch over 7 days? So this is the same as 7 over 2. Times by 2 times the first term, which is 7, plus the common difference, which is 3, times by 7 take 1. So now what we have is 7 divided by 2 and times by 14 plus, so 3 times 7 take 1, that would be 18, like such. Okay, we can work it out by hand. This is the same as 7 over 2 times by 32. 32 divided by 2 is 16. And then to work out 16 times 7, that's simply equal to 112. Okay, so that means he caught 112 fish altogether over the week. Pretty good fisherman. Okay, this is our next question. Find the sum of the first 16 multiples of 5. Okay, so multiples of 5 are 5, 10, 15, 20, etc., etc., etc. So we need to find not only what the first 16 are, but then also add them individually, right? I'm not bothered to do that. So what we can do is just employ, again, the arithmetic series. So Sn equals to n divided by 2, 2a plus dn minus 1. So in this case, we get 5 divided by 2. No, that's wrong. We need 16 multiples. So the number of multiples we need is 16. That would be S of 16. So 16 divided by 2 times by 2 times the first term, which is 5, plus the common difference between each term is going to be plus 5. So we can do plus 5 times by n take 1. And n, in this case, again, we said was 16. So 16 take 1. To work this out, we can simply say 16 on 2 is 8. So now 8 times by 10 plus 5 times 15. And 5 times 15 is simply just 75. So now that we have that, we can do 5 times that is 75. So now we have 8 times the value of 85. Okay, and that would just give us 680. So the sum of the first 16 multiples of 5 is simply just 680. Okay, here's our next question. So there are 110 logs in total, and they are to be put in a pile. So there are 15 logs on the bottom layer, so you have 15 logs going across like this. And then you have 14 in the next layer, so 14 stacked on top of those 15. Then you have 13 on top of those, and it keeps going forever and ever and ever, until you use up all your 110 logs. So how many layers will there be? So we know that in the first layer, there are 15 logs. In the next layer, there are 14 logs. In the next layer, there are 13 logs, and so on. Okay, so I'm just going to write that down. 15, 14, 13, etc. So this is our sequence of terms for the number of logs in each layer. So we need to sum up all the terms in this sequence until we get to 110 and no more than 110. So we know that if we employ our series formula, okay, in this case n on 2, 2a plus dn minus 1, okay, we know that the sum of the first n layers, okay, we don't know how many layers there are, they must not exceed, okay, it must not exceed 110. But we know the sum of the first 10 layers must be 110, or the sum of the first n layers must be 110. So the sum can be equal to 110, and we don't know what the value of n is. That's what we're trying to solve. So n on 2 times by the first layer will have 15, so that's 2 times 15. And the common difference between each layer is simply minus 1. Each layer you go, there will be negative 1 logs there. So negative, so minus in this case, n minus 1. And again, we don't know what the value of n is actually going to be, so that's our goal to work it out here. So 110 equals to n on 2 times by 30 minus n plus 1. And in this case, this is the same as 31. So now what we do is we can expand this out. So we get 31 on 2n minus 1 on 2n squared. Okay, and we could solve this either by hand or using a graphing calculator, but let's do it by hand for this video. So we can rearrange this whole thing to get half n squared minus 31 on 2n plus 110, and that equals to 0. Timesing everything by 2 will allow us to get n squared minus 31n plus 220. Okay, so now that we have this, we can simply factorize this quadratic, and two numbers I can think of are n take 11, n take 20 equals 0. So in other words, we can just say that n can either equal to 11 or n can equal to 20. Now, it wouldn't make sense for the second number to apply, because wouldn't you agree the number of logs will eventually get depleted after 11 layers, right? So the negative is just accounting for when the sequence enters negative numbers. But because we get n equals to 11 here, that means this is the number of layers that we will have so that we can pile on all the 110 logs. Okay, this is our next question. The sum of the first n terms in a sequence is 660, and we know the common difference is 4 and the first term is negative 5. So work out what is the value of m in this case. So what we're going to do is we're going to set up our series equation. The sum of the first n terms equals to n on 2 times 2a plus dn minus 1. And we know that the sum of the first m terms is what we're trying to work out. Okay, so in this case, m on 2. We know the first term is negative 5, so 2 times negative 5. Plus the common difference is 4. And in this case, we do m minus 1, because that's the amount of terms you want to work out. So we know the sum of the first m terms is simply equal to 660. So we have this. Now if we evaluate this equation, we can say that 660 is equal to m on 2 times by minus 10 plus 4m, take 4. So now working this out, we get m on 2 times by negative 14 plus 4m is equal to 660. Then what we can do is we can expand it out. So 660 equals to minus 14 on 2m plus 4m on 2. In this case, this simplifies to minus 7m and 2m squared. So now we get 2m squared minus 7m plus 660, in this case, take 660 equals to 0. And we can solve for m. Okay, if we solve for m in this case, we get m is equal to either 20 or negative 16.5. And it wouldn't make sense for negative 6.5 to be a solution because we're only considering positive terms. So in this case, m is simply equal to 20.